All right, this video is to equip anybody who's interested in doing the extra credit regarding the distance formula to be able to do it. And if I look the same like I look in the fun fair video, it's because I'm recording these videos back to back. So this video is going to go over the distance formula. Where does it come from? How do we use it? And then who should be doing it at this point in the course or in the project? Because not everybody, I would not recommend that everybody would do it because it is extra credit. So where does it come from? I am going to be writing with my finger on the computer screen. So it actually comes from the Pythagorean theorem. So if you have like a right triangle, okay, and the sides are A, B, and C, we know that the Pythagorean theorem says that A squared plus B squared equals C squared. Or if we switched the order, this is the symmetric property of equality. You could say C squared equals A squared plus B squared. And then to undo squaring, we square root. So we would take the square root of both sides, and the square root of C squared is just C. And what you see there is essentially the distance formula. It's just like a sanitized version. And any time that you have to find the distance between 2 points and you blank out on the distance formula, you don't remember where it comes from. So just remember it comes from the Pythagorean theorem, and you can use the Pythagorean theorem instead, because that's pretty much all it is. Now the distance formula looks something like this. So I'll get it up there on the screen. It's D equals x2 minus x1 all squared minus y2 minus y1 all squared. And if you look at it, you can kind of see the similarity where A is just the distance between the two x coordinates. So to find the length of the horizontal side of the triangle, you would just subtract the two x numbers. And then B is the y value. And that's a minus sign. That I kind of messed that up, and it looks like a plus sign. I don't want to leave it like that because somebody will get confused. So not that that's a whole lot better, but at least it doesn't look like a plus sign. So that's pretty much all it is. And then you're using a D, but as for the distance between the 2 points instead of C. And that's like pretty much all the distance formula is. So that's where it comes from. And it's actually really useful to remember that it comes from the Pythagorean theorem, because a lot of people will forget the distance formula because it kind of looks like a mess. But the Pythagorean theorem, most people remember that from middle school. So how do we use it? The distance formula is used to calculate the distance between any 2 points on the coordinate plane. And the advantage that it has over the Pythagorean theorem is that the distance formula will handle negative coordinates, and it will also handle things like decimals or really big or really small numbers that you might not necessarily ever want to try to graph out and measure. So I have a couple of examples. Like, suppose we want to find the distance. So here's our formula. So x2 minus x1 plus y2 minus y1 squared. There we go. And we want to find the distance between -3, 4 and 1, 2. Okay. And so what you would do is you would pick a point for point 1 and pick a point for point 2. It really doesn't matter which point is which, as long as you're consistent and you don't change your mind partway through. So if I call this point 1, then that becomes x1, y1, and this is x2, y2, and you just want to be pretty consistent when you go to plug that in. So x2 is 1, x1 is -3, like nobody really likes that, okay? So 1 minus -3, and the reason for that is because you have the whatever that is, the minus in the formula, and then you have another minus that's coming in with your value of x there. Plus y2, which is 2, minus y1, which is 4. And now we just do order of operations. So 1 minus -3, that's just an awful way of saying 1 plus 3, which is 4. And then 2 minus 4 is -2. And then we'll square it. Make sure you're following correct order of operations. The square root acts as a grouping symbol. So this becomes 16 plus 4. And so we'll have the square root of 20. Now here's where it gets a little weird. Like for engineering purposes, you would probably just grab your calculator and just do the square root of 20 and convert it to a decimal. And the reason for that is because engineers are interested in like practical use of stuff. So it's not going to be of any practical use to you to have that in square root form. So that's about 4.47, whatever units you're in. If you're in math class, like in math class, the rules are a little bit different. In math class, you gotta go with like the math idea that like a simplified radical is what you want. And so you would look for a perfect square factor, which would be 4, and the square root of 4 is 2, and you would leave it like this. So this is like how your math class would do it. This is how your engineering and usually your science classes would do it. And that's just because those two different disciplines just approach math differently in what's considered like the best form of an answer. So how does this apply to this project? Well, you guys have your whoops. Oh, okay. That was very weird how that happened. Okay, so you have your target, and then you have all these points like around your target where your beanbag landed. And for extra credit, now for regular credit, you're just taking a ruler and you're measuring the distance from the origin. For extra credit though, you can actually do the calculated distance. Now what makes this good is that sure that I have, okay, 6, -3. Okay. So we're going to call this the point 6, -3, is that your first point is the point 0, 0. So that actually makes this really easy. You're looking for the distance between some point and the origin, which has the coordinates 0, 0. So when you go to plug that in, so if you have like your x1, y1, I don't know why I did it that way. Let's call that x2, y2. Wait, let me model good. I got a model doing this neatly because I don't want to be a hypocrite. So we have what, 6, -3, and then 0, 0. So I'm going to make this x1, y1, and this x2, y2. Remember, it doesn't matter which way you do it. It's just, this is a nicer way to do it. So here's the deal with this. When you do x2 minus x1, it's just subtracting like 0 or adding zeros. So you're always going to be subtracting 0, I guess, on this one. So like you don't even need to bother with the 0 part. So this is just 6 squared, which is like 36 plus 9, which is the square root of 45. And then for your purposes, like you really want the decimal, which I think for a lot of you is probably going to be like a relief because you really don't want to simplify the radical anyway. And then make sure you do round correctly. And the last thing that this video is intended to talk about, so that's your extra credit. So who should be doing this? Students that have finished everything else with their project and you're just waiting on other groups to finish. If you have the time and you're just waiting, like I don't want you twiddling your thumbs, like I have nothing to do, so I'm going to, just be a ne'er-do-well. Like work on this, like do the hand calculations out and put that extra table into your data table. You don't need to do this if you are already behind, but if you feel like your grade needs a little bit of a boost, if you can divide up divide and conquer for that, that's fine as well. So hopefully this video helps some students with their distance formula so that you know how to make it work for you in this particular project.